Welcome back. So we're going to try example 3 of section 4.3. So we're going to take the derivative of this function, and if you notice, by looking and analyzing the function that we have a function over another function. So we should be thinking what kind of rule are we going to be using here. And of course the rule here we're going to be using is quotient rule. So if we think about the quotient rule, is going to be u prime times v minus u times v prime all over v squared, right? And so we're going to follow that in this example, right? So we have g prime of x is going to be all right. So we follow the quotient rule here, and so this is by the quotient rule. And so all we gotta do now, because we just follow the quotient rule, all we gotta do is come back and execute the derivative of those, right? The derivative of e to the ex is going to be e to the ex, right? And the derivative of 5, well, that's a 5, that's a constant, so that's going to be just 0. We carry the rest of it, the other factor, and then we're going to multiply this by e to the x plus 5, and now take the derivative of this. So derivative of this, for the first part, we're going to just use basically constant multiple with the power rule, and also constant multiple and power rule, right? Multiply and subtract, right? So this will be 4 times 6 times 4, it will be 16. So 16x to the third plus 6 times 7 is going to be 42x to the 6 all over your denominator. And let me try that again. I don't like it. So let's try that again. Anyways, I don't have to make this straight line, so just like that. And then the bottom is just going to be the same thing. There you go. And there's no need more to do from here, right? I don't expect you guys to factor this out or simplify it. And I almost forgot my parentheses here. So this is it, right? So I encourage you always to follow the quotient rule and set it up, right? I think this saves you a lot of mistakes just by setting it up. It's very simple, just an extra line, and it's very helpful. All right.